Well, where we just left off, there was a problem. We did the upload, at least it appeared that we did the upload, and yet the board doesn't seem to be doing anything. It is time for us to do some debugging, our very first debugging. We already found some bugs. How about that? So, does the board have power? Yeah, it has power. I can see the on light is on, so that's a good sign. Did the board get the instructions from the computer? Did it talk to the computer? When we tried to push the instructions, was that successful? Well, we saw those TX and RX lights doing a whole bunch of blinking, and the software says done uploading. So that means that yes, the board did get the instructions. So what's the problem? Why isn't it blinking? We need to kind of go on a hunt and try to solve the problem. Let's look at our code. And I say let's look at our code because the problem could be in hardware, it could be an electronics problem, or it could be in software. Those are generally the two places we're going to be looking, but there's really no hardware to speak of here because there's nothing plugged into the board. It's just the naked Arduino board. If we had a bunch of electronics plugged in, perhaps we would have a problem in our electronics. Here, there's only one place to look. Let's look at the software, see if we can find the problem. So we are guaranteed that the problem is not a comment because the computer doesn't read the comments. So let's look below it. Let's see the actual meat of this program. And by the way, this program only has 1, 2, 3, 4, 5, 6, 7 lines of actual code. The rest is comments. The computer doesn't care. The first thing the Arduino is going to do when it first powers up is it's going to turn pin 13 into an output. So far, so good. That only happens once because it's in the setup, and the stuff in the setup runs once and only once. Then it'll be done with the setup, it'll exit the setup, it'll enter the loop. When it enters the loop, it's going to run line 22. It's going to send electricity out of pin 13. Because pin 13 happens to be connected to this light, whenever electricity is going out, that light should light up. The next thing it's going to do is line 23. It is going to stop sending electricity out of pin 13. What's the next thing after line 23? Well, they call this a loop for a reason. The next thing that happens, after line 23 is it goes from the bottom to the top. And that is exactly what's going to happen. Line 23 is going to run, followed by line 22. Then, of course, it's just going to read top to bottom again. It's going to go 22, 23, 22, 23, 23. So it's going to be alternating those two lines of code. That's what blinking is, right? Why isn't it blinking? What is the problem? I see no errors. Well, in this case, the error, if we want to call it that, the bug, is actually in your eyeball because the Arduino is blinking that light. It's just blinking it really fast. It's in fact running line 22, followed by 23, followed by 22, followed by 23, so quickly that you are literally not able to perceive the blinking happening. Now, if you want to try something out, what you can do, and it's not going to show up well in this camera, but if you shake the Arduino in a relatively dark environment and try to kind of hold your eye still, you will see that little light tracing out little dots across space as you move it across space, indicating that it is in fact blinking. It's going to be difficult to see, and if you're in a bright environment, probably nearly impossible to see. Another way we could see if it's blinking is attach an electrical testing device like an oscilloscope, which can detect voltages changing at high rates, but we don't want to do either of those things. I'm telling you what the problem is in this case because I happen to know what the problem is. In the future, you need to do your own debugging, and you will not begin by knowing what the problem is. But sometimes it's working. It's just working in a way that's invisible to you. So it's blinking too fast is the problem. Let us solve the problem. Well, it's purely a software matter. What we need to do is slow it down. Fortunately, there's a command for that. The command is called delay. I'm going to write it like that. I'm leaving it sort of in an incomplete form for the moment. And what delay will do is wait for blank, blank, blank milliseconds. When I say wait for that many milliseconds, I mean do nothing at all for that many milliseconds. So let's say I put the number 123 in there. It will wait 123 milliseconds. A millisecond is 1,000th of a second. So just for clarity, that equals 0.123 seconds. Sorry. 0.123 seconds. Okay, so now we have modified our code and we can just upload it. Hopefully we fix this blinking problem. It'll have a little bit of a blink. It'll wait for 123 milliseconds in between blinks, right? So let's give it a shot. It's as simple as hitting upload. So you're going to be modifying code, hitting upload, modifying code, hitting upload all the time. It is not bad. It's not harmful to upload new code. Just go for it. No problem at all. Let's try it. Upload. And this did upload the code. I saw the blinking happen before, and now the light is just stable and on. Not blinking. What's the problem? Well, let's again look at the code, debug the code. Let's just go top to bottom. It starts by making pin 13 an output. So far, so good. It enters the loop. It executes line 22, turning on the LED. It then executes line 23, which is delaying doing nothing for 123 milliseconds, in this case, 0.123 seconds. During that time, by the way, I want you to think of a delay as a just freeze. So if somebody is walking and you just like freeze the frame, if their hand was up, it remains up during the freeze. If their hand was down, it would remain down during the freeze. Delay does not mean turn everything off and go to sleep and wait for that amount of time. It just means pause. Don't change any output. So if it was already outputting a high signal, it will remain that way. If it was already low, it will remain that way. Okay. So to start again at the top of the loop, it turns on, it does nothing for 0.123 seconds, and then it turns off. What is the next line that executes after 24? Well, it goes to the top of the loop. So it goes back to line 22, and it turns back on. So how long was it off? That's the problem. It was only off for like a minimal amount of time. How long in reality? It could be like a millisecond, could be less than a millisecond. It's however long it takes the Arduino to get from the bottom of the loop to the top, which is not 0, but it's pretty quick. So again, we wrote code. The Arduino is doing what we told it to do, but it is not our desired outcome. So we have to improve our code to make it be the desired outcome. I will simply add another delay below the second command. This is the solution. We need it to stay turned off for some amount of time. And in this case, I'll wait, I don't know, it could be a funny number, 482 milliseconds. I'm just choosing funny numbers just to show that you can put anything you want in there. Not truly anything, but a pretty wide range of things. So now this will be on for 123 milliseconds, then off for 482 milliseconds. What's the next thing that will happen after it's off for 482 milliseconds? It'll turn back on. So now we should finally get some blinking action that is visible to the human eye. I'm going to go ahead and upload. I'm going to see the uploading happening, blink, 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 the TX and the RX, and aha, finally, this is actually blinking. We finally wrote and then debugged our very first sketch. Great. So this is a great point of entry to the next place we're going, which is adding more stuff that is not merely the onboard light. However, before we get to that, I do have a fun challenge. I want you to get the Arduino to say SOS. SOS is the signal you send when you are stuck in the middle of the ocean and you're in trouble. You send an SOS via Morse code. How do you do that? You do a short, 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 long, 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 short, short, short. This short, short, short is an S. That long, long, long is an O, and that's another S. So the short could be like da, 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 and then the longs could be da, 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 and then the short could be da, da, da again, where the da, when I say da, that's the time the light would be on, and when I'm silent, that's the time the light would be off. So I invite you as a challenge to get your Arduino to send out a little distress signal because something terrible has happened in Arduino land and it needs help. Go ahead and make it send out an SOS code.